So hello, everyone. I'm Stéphane Lafortune of the Electrical and Computer Engineering Division in the College of Engineering. So today our guest is Linda Zhang, who's the Vehicle Programs Director for Electric Vehicles in the Model E organization at the Ford Motor Company. Before assuming that role, Linda was Chief Engineer for the all-electric Ford F-150 Lightning. So in that capacity, she led the team that delivered Ford's first all-electric F-150 pickup truck, which was quite an accomplishment. Linda received 3 degrees from the University of Michigan, including a Bachelor of Science in Electrical Engineering, a Master's of Science in Computer Engineering, and after working a few years, she came back to U of M to complete her MBA. She's a member of the Alumni Council of the ECE division, and she was recognized with the College of Engineering Alumni Award in 2022. She's also a member of the Automotive Hall of Fame. Linda, thank you so much for taking the time to answer our questions today for our class. And I'd like to begin by asking Mark to start with the first question, please.
My first question is, I was just wondering if you could tell us about your role in bringing the F-150 Lightning to market and the technical specifications of the F-150 and why they were important.
Yeah, absolutely, Mark. Thanks for the question. And Stefan, thanks for the great introduction. Go Blue. I obviously love my U of M with 3 degrees. But I had the pleasure to be the chief engineer for the F-150 Lightning. And my role was really taking the product from concept to production. And in this case, it was an electric truck. And in all honesty, it was a really exciting role because back in 2020, there really weren't any electric trucks out there in the market. So when we started this project, it was a white space project, and we were really defining what this new segment meant. And that's where, I think you mentioned technical specifications. That is actually truly important because what technical specifications do is really take what the customer does with the vehicle and translate that into engineering speak so that we can then design the right product and have everyone working toward the same goal. So, when we first started this, because it is a white space in that it's an electric truck, we wanted to make sure that we really thought through what it meant and what specifications were important. So first we started talking about, well, it's a truck. We know truck really well at Ford Motor Company, 45 years of sales leadership in that. And truck DNA is something that we know really well. It had to be powerful. It had to be great on-road and off-road. It has to be able to carry payload and to be able to tow. And it has to last a long time and be durable. So these were the customer attributes that then we had to find technical solutions with a new electric vehicle technology and electrical architecture, right? Not just the same solutions that we had in a gas vehicle because the properties are just so different, but new EV technologies to try to make sure that we are all of these things that a truck really needs to be, right? And with our truck history, that was not too difficult, but still required a lot of work. And then we turned our attention really at the same time, but separately talking through, well, what does that mean for an EV? What would be the DNA of an EV? Well, we know from some of the vehicles out there and our Mustang Mach-E alone that, it's quiet. It's a very different character in terms of quietness from not having an engine. And now you're just dealing with road noise and wind noise. It's fun to drive. So how do we make it even more fun to drive where like the power literally blows people back and they're like, holy cow, that was a truck. And then, just the torque and the 0 to 60 that fun to drive really delivers using those technical requirements and making sure that the specifications are written so that we do get that instant torque and that 0 to 60 in less than 4 seconds. So really, it was a really great, new, exciting opportunity for us at the vehicle level. But as we sat and worked through all of this even further, we found new opportunities where we thought through, where this electrification of a truck really unlocked new capabilities that neither a truck today or an EV today really is able to provide our customers. So one example is exportable power. This vehicle, because it's now sitting on this giant battery pack instead of having an engine up front, now has really just a battery, right? You can think of it as a spare battery, literally that's on wheels. So a generator on wheels. And if you're out in the forest, it doesn't matter if you're there or if you're tailgating or anywhere else, you have this capability to be able to run electricity anywhere you go. And also at home in like a power outage. I actually just got to use that last weekend when we were out of power for 7 hours, and it only took about 5% of range out of the truck. So it was pretty great. And then, even beyond that, this concept of a front trunk. EVs do have a front trunk, but they're not super exciting. They don't open by themselves. They're definitely not truck, right? And in truck, when we go do something, we generally do it big. So we said, well, we can't just do a little teeny tiny frunk. Frunk is the term for a front trunk. We have to make this like big and powerful. So we actually coined a term, mega power frunk, because we wanted this to be mega, right? It was going to be 400 pounds of payload, 400 liters of volume, just huge, any way you think about it. We wanted to make sure it had power, right? We talked about this capability of drawing power from the battery. We wanted to be able to allow our customers to draw power from the front. So instead of just tailgating in the back, now you're front gating. Right. And in this Frunk, those were the specifications that we had to think about. Right. So just in the Frunk alone, all of the different things that we worked into it, basically translating what the customer could possibly do with the space into what specifications needed to happen, right? In terms of the exportable power capabilities, the fact that, these struts that open and close on a regular basis had to meet durability for a commercial truck driver. The fact that, we're going to have people tailgating and maybe sitting in there, right? So, what is the right payload? In our case, we decided 400 pounds. And then even at the bottom of this frunk, we had a drain, and just the requirements that went into that drain alone, right, to make sure that we don't have dirt and debris coming up into this secure, lockable, dry storage. It just, the specifications there's so many technical specifications, but they're all really important. And I think the point of it is we really valued what the customer was going to do with this product. And we thought about how we best translate that customer usage and what the customer needs, whether it's, the functional safety of the Mega Power Frunk or the performance of it, whatever it might be. We wanted to make sure we translated those into the proper technical specifications so that the customer can get the most out of the truck.
Linda, can I ask you a question about weight? So how does the weight of the electric F-150 compare to the gasoline engine one?
It is more. Just the battery alone is about 800 pounds more, to about 1,000, really depending on which battery pack. We have a standard range and an extended range. So that alone is more. And then, of course, because of that battery pack, you need more structure to go with it, right? So in terms of specifications, we did have to do quite a bit of modeling to see what is the right kind of fine point, because you don't want to put too much structure in, because then it's it's more heavy than it really needs to be. So yeah, it is a little bit more weight wise, but that's really just because of the technology differences between an engine and transmission translated into a big battery pack with, in our case, two smaller motors, one in the front and one in the rear of the vehicle.
Okay. Yes.
Yeah. So, it's a lot of fun. The specifications were important for us, right? But the point is, you have to look at it from that customer mindset and bring together the best of both worlds in our case, right? The truck and the EV. And we do that really just for the customer.
So what about those electric motors? Were they, you knew beforehand which motors you were going to use, or you had to get them commissioned specifically for the F-150 or?
Yeah, they were a commission special for the F-150 with the right level of requirements for towing and for heat and acceleration and just a lot of these different requirements, right? It basically plays on it. And that's what's really, really magical about the product development phase and particularly the planning phase, because you kind of plan it based on where you think you're going to end up. And then as you keep progressing the development, you tweak it to make sure that it meets what you need. And then you test it and you might have to tweak it some more. So, and then the goal is to do all of our tweaking before the customer gets the product.
Thanks. Lydia?
Well, first of all, thank you so much for meeting with us. And then, so as you're mentioning all of these specifications and everything you're doing to kind of plan and put together this vehicle in the Ford F-150, what were the greatest challenges you faced along the way? And what were kind of those, setbacks in your product design, or where you kind of had to retweak or rethink different steps along the way?
Yeah, no, that's a great question. And, I'll give you two examples. One is, we just talked about motors, right? And the fact that those were sized for a truck. And one of the greatest challenges actually came in the middle of that development process, because we did some very early on testing, and some of you guys may even have seen it. We went and towed a million-pound train, with a prototype truck. And part of that was really to just test out this motor and this battery and what our capabilities were. And from that, as well as other testing, we actually realized that we had a little bit of a problem in our motors. We had to really think about whether this vehicle could tow with the motors that we had selected, and tow in the form that like a true truck customer would need with 10,000 pounds of towing. And what we found was that when we did that over a lower incline, right? Because a lot of our testing requirements and a lot of the specifications that we had really had us working toward what a traditional gas truck problem would be, which is, can you get up a high incline? Nobody really understood that, the high incline for an electric vehicle is no issue because you have instant torque. You can go up that incline, no problem. But what becomes more difficult is when you're actually going up a lower incline for a very long time. So when you do that, we actually had an issue with our motor overheating. And we really faced a major challenge where we had to think about, well, what would it take to redesign these motors? We had to internally go in and change bus sizes, be able to add more cooling and just do quite a bit that actually took longer in the development cycle than we originally planned. So it meant a 3-month delay to the product. And as a team, one of our goals was to be first to market with this electric vehicle because, in a way, with being first to market, we get to, like I said, establish what an electric truck means. So we really had to think through that quite a bit. And we had a lot of discussions, and I think, for sure we made the right decision. We delayed and we said, we're going to fix this because one, it's important for our customers to know that this truck is credible. But two, it's an F series truck. And from a brand perspective, F series means a lot. And we can't go tarnishing that F series shield. So for us, it was all about doing it right, making sure that the product stood up to the brand. And that was one of the biggest challenges, just because it was so impactful to the total program in terms of the delay. But the team actually did a really good job, even though we took the 3-month official delay in the product. The team actually did a great job of doing it actually faster, so we could get it back out to the market faster. So we actually did better than our initial 3 months, which is good. And I think the second challenge I want to bring up, which is a really interesting one, is, and it's not so much engineering related, but it is really important as we think about products and customers, because it is important from a customer perspective. And that is really just how do you bring the customer along on this journey when it is such a revolutionizing product? When I first started the product, there was really like an electric truck was almost an oxymoron, right? Because electric vehicles aren't known to be tough and trucks are tough. So therefore you had this almost like is it does it make sense to the customer? And we had to bring them along. And that was where it was really important for us over the few years that we worked on this, is showing our customers what this product was, and not just telling them, right, but showing them, because of the fact that we're not trying to go after the early adopters. We're trying to go after the mainstream customers, where for them it was important to not just be told this grand promise, but to show them that it's truly capable, it's truly durable, it can do all these things that we're talking about. And look, you can touch and feel the Mega Power Frunk, and the fact that we're towing a 10,000-pound trailer and you're in the vehicle and it feels magnificent, right? Those are the important things. So that was another really great challenge. But as a team, our marketing team and our media comms team did a great job of making sure that we set that up with the timeline of the product, so that we could kind of do both at the same time, develop the product and also showcase the product to bring the customers along.
So I'm kind of curious if I can ask a follow-up question here.
Absolutely.
You mentioned going up, a small incline for a long time, right? So I'm curious about going downhill for a long time, given the extra weight of the vehicle. Do you have any special requirements for, I suppose that braking helps to recharge the batteries?
It does.
You have to adjust that, the ratio of
absolutely
recharge versus brake pads themselves, or?
We do, yeah. And that's one of the great things about an electric vehicle, especially going downhill, is that you get range back. It's kind of comical because we have a lot of EVs in our household now. And it's funny because when my husband tends to get it close to like the 50 miles left, I'll get multiple sensors or multiple notifications that it's low on charge, because it'll regenerate depending on what you're doing, including just driving down the street. And if you're going down a hill or even decelerating in any shape, right, even at coming up to a stoplight, the motors basically take that energy, instead of it wasting into heat and dissipating with brakes, foundation brakes, you end up retaking that energy and putting it back in the battery. But if you're continuously going downhill, at some point the battery does get full, and then we have to start making sure we apply the brakes. So, like to your point, there's actually a quite a big brake calibration that goes in to make sure that from both a powertrain perspective and a braking perspective, that that there's the right level of control, so that we're regenerating and recapturing that energy in the cases where we should, and that we're applying more foundation brakes when we can't take in any more energy.
Do you know how many lines of code are in the F-150 electric, and is it more than in the gasoline engine, or one?
I don't know how many lines, but I'm sure it's a lot more, because we have a lot more electronics and capability and modules. Just even, with the phone as a key, for example, where you don't have to carry a key because it's all on your phone. Like that has a ton of lines, and that's a feature that's only on the F-150 Lightning. It's not on a gas truck yet.
I see. Okay.
And then I also had a follow-up to what you were saying when it comes to the challenges in kind of selling to like buyers, especially in the truck sense. What were, I don't know, like the biggest things that if you're converting someone, say, from a diesel or a gas truck to this electric truck, because I could see a lot of people kind of being like, oh, like I'll buy a truck now, like they have an electric one, but how did it work, and how did your group and team work to get those hard set customers who loved their gas trucks into the electric field of trucks?
Well, I think a lot of it is just people are just so excited once they get in it and they experience it. That acceleration, I can't even tell you, like literally, it feels like you left your stomach a mile back. So, that's been a great way of getting customers who said, "Oh my gosh, I can never take an electric truck. I need my power and I need my capability." We get them in a truck and they like it. We call it button seats, right? Once we get butts and seats, then they are sold. We actually had one of our plant workers. He was a leader on the team, and he was dead. He was going to be putting this truck together, but he was dead set against buying it. And once we got through the prototype phase and he got in a truck and he was moving them daily from one A to B, he literally told me, he walked up to me in the plant and basically said, "Linda, you've absolutely ruined me. You've ruined me. I can't go back to my gas truck now. I put my order in for the electric. I want it so bad. And I'm however many in line." And he's like, "I'm going to watch my truck get built." All the way through the process. But he was one of our diehard examples, right? He told us up front, I'm happy to put this truck together, but I'm never buying it because I am a hardcore gas customer. But he was fine and he loves it. I still chat with him quite often.
So that's the power aspect. What about the other issue that people raise, which is range anxiety? How did you address that?
Yeah, range anxiety. Well, I mean, there's not too much to address because it's physics, right? A lot of it is, when you tow, whether it's a gas vehicle or a electric vehicle, it takes up more energy, so therefore it takes more, energy, electrons in this case. So there's really not too much we can fix other than designing the product to be as efficient as possible, and then also I think a lot of it is just as we talk through the future of electrification, where charging becomes a really important aspect. And I think it's interesting because it's really what we found is it's not so much range anxiety, but it's charging anxiety, right? Because if we had chargers everywhere, then it would be much easier. So that from that infrastructure perspective, it is really important for us to continue to develop that as electric vehicle volumes go up, because together those go hand in hand. And it's just so important for us to make sure that our customers can find charging, reliable charging, fast charging, and go. But I mean, like I said, I have three electric vehicles, and we've taken it on vacations. We went out to the Outer Banks and the Lightning, and we really didn't have any major issues. It was just you have to plan a little bit better because of the infrastructure, and it definitely takes longer than getting gas. But at the same point, we found that it was actually beating us in terms of our human needs, right? Of having to stop and get food to eat or stop for a break or whatever it is. We tended to we'll get a message on my watch when the truck is charged to a point of it's ready. And most of the times it went off before we even got back to the vehicle. So I think, again, it's just something that, as customers get more aware of the product and more into it, it's a little bit of a habit change, but it's a great one because you also don't have to go to a gas station.
Sorry, I just wanted to ask, how long does it take to charge?
Well, it really depends on what you're trying to get to. Honestly, most of my charging happens at home, and that's what we see with most customers too. Over 90% of customers really just charge at home because of what they need to do on a regular basis. It becomes that 1-2 trips a year that you're going to need to use fast charging on the highways. And generally, because of the battery and us trying to make sure that the electrons aren't flowing too fast in certain situations, this is where, back to the technical specifications, you actually end up with a charge curve that charges at a different rate depending on what your start is, what your current state of charge is, right? The SOC. If your SOC is super low, it might be a lower because it's trying to protect battery a little bit. And if it's high, then you also lower the the speed because you don't want to, cause any issues with the battery. But in the middle there, like basically between like 15 to 80% or even 90%, that's where the sweet spot is in terms of being able to charge faster. And most of the times you can crank, like at least in the Lightning truck, you can crank about 170 kilowatts through. So that's pretty quick.
Wow.
And it's about 30 minutes of charging, sometimes less, because again, it depends on what stops you're at. But we really try to make it as convenient for the customer as possible by making sure that we have the digital applications that go with it, like in our Ford Pass, which is our mobile application. You can actually map your routes out and it'll tell you exactly where to charge and what your start charge is and where it thinks that you need to be, you can be done. And then that's when it also sends a message to your, Apple Watch, for example, to say, hey, you've reached the charge that you needed to get back in the car, right? So we try to make it as user-friendly as possible, knowing that it is still definitely something that takes a little bit longer. Now, in our future gen products, we will definitely be working on charging even faster than that. I can't go into too much on that yet, but that is something coming.
Okay.
So I had a question about where you see the electric vehicles, especially in the truck sector, going, like how you envision the market to adapt and what are the next like big technological advancements that we're going to see soon with electric trucks.
Yeah, I mean, I think electrification is not really any different than any other technology, right? So from that perspective, at Ford, we expect it to be very much following the normal kind of Moore's chasm, right, and that rate of an adoption. And we're really at that point right now where, we're really migrating from those early adopters to the early majorities, and then later to the late majorities. And that'll be kind of where we see us heading in the next, few years. Really by 2025, there's a lot of expectations out there that EVs will be about 25% of new vehicle sales. Mm-hmm. And by 2030, that it might be 50%. So I think it's definitely going to increase. And I think as more people get into the product, they see the benefits of it. And, as a product team, one of the things that we really focus on is how do we help transition? How do we help with the transition from ICE products to EV products for those customers, right? That are, moving from the early adopters to this mainstream product? Because in reality, like with the early adopters, they're more willing to deal with, we kind of call it the bleeding edge of technology, right? They don't care if it's difficult to charge or if there might be issues. They want to be that really, really edge of the technology, and they don't care if it's perfect. But with the early majorities, they do care. They want to know that they're going to be able to charge faster and that they'll be able to that it's affordable, right? Those are the other things that are really important. And, how do we deal with range anxiety? How do we deal with charging infrastructure? So those are all things that we're working on, before the Lightning, and then also continuing to work on now is just continuing the show, don't tell, right? Because this new this early majority needs to be shown that it works. So part of it is trying to get through that. I think from a technology perspective, there's always going to be, more and more technologies. We work through those all the time. At the university, you guys are working on a lot of really great things too. And at Ford, we are as well. So, there's definitely more coming in this space. And I think that's what's great about this is because there is so much interest, and there's just a lot of excitement in this area.
So, Linda, can you tell us about your current responsibilities now at Ford?
Yeah, I can. So I was the chief engineer before, but toward the end of last year, really, pretty much December timeframe, they gave me more scope. So now I'm the director for EV cars and utilities. So I manage not just the one product like a Lightning, but I manage several products in the car and like utility space. So that'll be like Mustang Mach-E, for example, is one of my products. And then we've got a lot of other future products coming in the space. So those are also mine to manage as a whole. So yeah, a lot going on, but it's a lot of fun too.
Great.
I had a follow-up kind of to, you discuss a lot about range anxiety and then charging anxiety and how you're trying to work to build that infrastructure to continue the switch to EVs. And as someone who lives in a very small rural town where there's probably the nearest charging station is probably 3 hours away. And as I feel like most people in my town do own trucks, it's a rural farming community. And I think that's like the case for many places in the United States where those more rural areas are where trucks might be more common than say in bigger cities where they have the infrastructure for charging stations. What would you say, not that you really have much of a say on where charging stations are built, but what would you say kind of as a product designer and as somebody who works well with customers, how does that kind of relate to your push of electric vehicles and that charging anxiety?
Well, I think, there's definitely a lot of fronts to it. As individuals, it's with an EV, we encourage our customers to actually install charging in their own home. And that's where, like I have two chargers actually at my house, one for the Lightning and then one for originally for the Mach-E, but now we kind of just rotate all the vehicles through there on a regular basis. But I think, like that's one major aspect, right? Once you have that charger, wherever it is, rural communities or urban communities, it becomes it changes the dynamics quite a bit. And you're basically never having to go to a gas station. You wake up every morning to whatever state of charge you set the vehicle to. I generally set it to 90% because I want to leverage the region. And again, it just depends on what's going on. If I'm going on a trip, I'm going to set it to 100, but every other day I set it to 90. But you're leaving every morning with 90% of over 300 miles of range. It actually is more than 300, even with the 90%. So it's pretty nice. You can go a lot of places on 300 miles. Generally, we're not always the best at charging the truck or our other EVs on a daily basis, just because, you don't have to, right? You get into the pace of it and then it's like, oh, I need to charge this twice a week, maybe, right? It's more like once a week sometimes. So I think that'll definitely help. And I think the other bit is for public infrastructure. Absolutely. I think every community probably needs it. And I think there's a lot of incentives out there that the government's put out with the IRA bill that really helps with that. There's supposed to be one in every 50 miles along a major highway. So, that's where I think that'll definitely help boost all throughout the US, that infrastructure so that people can feel very comfortable going coast to coast.
Awesome. Thank you so much. That's really, really cool to hear, especially, coming from an area that hasn't been super electric vehicle focused. So thank you.
Yeah, absolutely.
And then I just have one final question for you. What advice would you give to undergraduate students with an interest in sustainability and then even combating those challenges you probably faced bringing the ideas of, I want to make a truck that's electric. So what advice would you give to students?
Well, I think it's a really exciting space and it's definitely growing. So from that perspective, it's always good to be in growing spaces because there's lots of jobs after you're done with school. And the technology behind it is really exciting too. And I think the other bit about it that people don't always immediately think about is that the technology that we're talking about for electric vehicles really requires a lot of different engineering disciplines, and even non-engineering disciplines. So, in my own opinion, I'm always, for me, it's super important to just absolutely love what you do. And I actually have a daughter in college as well. And what I tell her is, you spend so much time or so much part of your time, like as you're, living, working, and also like thinking about work, right? If you're doing it right, you're probably thinking about work even when you're not working. So it's just really important for me, like, to pursue whatever it is that you just absolutely love and are interested in, and whatever you think that you would like doing or love doing, as part of your career, right? Because it is such a big piece of us. And I know, like, there's a lot of disciplines out there. They're all super important for this product, right? Chemical engineers, obviously, for the, the transfer of the electrons, the electrical engineers, because everything's hooked up with electricity, and everything, the modules and the communication and the, the self-driving, all of those different things. But, all the other areas too, mechanical, aerospace, right? Range is so, because, you guys mentioned it too, range is so important. The aerodynamic shape of a car is becoming way, way more important nowadays. And we also need industrial engineers too, because we need it put together. And what's the best way to put, a battery together and make sure that we've got capability and such. So there's lots of disciplines. I'm missing a ton of them, but they're all super important. So I would just say, from that perspective, pursue what it is that you love, because you're going to be doing it. And, if you start it and you don't think it's right for you, then it's okay. Change paths. That's totally okay. You have a long career ahead of you, and just love what it is that you do. I myself have switched a lot. I started in manufacturing because I like the hands-on. I did product development. I did finance for a while. I did business development for a while and sold and bought companies. And I think all of that actually has made me a much better person for whatever job I took next. So don't be afraid to go outside of your comfort zone. It's okay not to know something. You guys are all smart. You wouldn't be at U of M otherwise. So just go and apply yourself to whatever it is that you love. And, if it's in sustainability, great. If it's in engineering, great. There's just so many opportunities out there. So.
Well, thank you, Linda,
Thank
for
you.
spending time with us and for this very interesting discussion. So really appreciate it, and all the best in your future projects. Thank you.
Well, thank you guys very much. Go Blue.
Go Blue.
Thank you.
Thanks. Bye.